So those are our asymptotes. And I actually want to show y'all. So on these graphs, it looks like it's touching the asymptote, right? It looks like it. So I actually want to show you an example of what's happening with our function, looking at it on Desmos, okay? So I'm going to do, let's just do 2. Oops, back that up. All right. So if I zoom this out, it also looks like it's touching my x-axis, right? Y'all see that? But the more that we zoom in, what is it actually happening? Is it touching it? No. You keep going. It keeps getting closer. That's actually at like 0.01. How big is 0.01?
Huge.
Not very, right? It's very tiny. So like that is barely off the line. And if we kept going over, now it has to be touching the x-axis now, right? Look at that.
Holy moly.
Now it's 0.00002, right? So it's getting closer to 0, right? But is it 0? No. Okay, let's try it one more time.
So like 500?
We'll do that. Maybe not 500, because that would just take too long to swipe all the way. All right, negative 58. Surely we're at 0. Let's zoom. You know, it'd probably be a good bet to make. Hence, why I'm showing. Uh-oh, I lost it. There it goes. It still looks like it. Oh, wow. Will Desmos not zoom anymore? No. But if we look at that, how many, when it says times 10 to the negative 18, that's going to be point 0.0000000000000003. How small of a number is that? It's like kind of ridiculously small, right? And so that's why we say it can get really, 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 really close to 0, but it can't touch it because it's gonna keep getting closer and closer and closer. At some point, it would be plus or point 0.000000000000000000000000000000001. But is that 0? No. It's almost 0. But is it?
No.
Okay, so that's what's happening when we look at one of these functions. The closer it gets to the x-axis, okay, the smaller our number is going to get, but it's never going to actually touch 0. It cannot touch the asymptote. And in our case, oops, wrong one. And in our case, what would the equation of that asymptote be? It's a horizontal line, so that means it's going to be y equals. But it's going to be y equals what? What's the y value on that entire line of the asymptote? 0. And so when we say it's getting really, really close to 0 but not touching it, that's what we mean. It's getting really close to where our y value is equal to 0. Colin, why don't y'all put your computers down? Yeah, let's go. We don't need our computers today, so we can close them. All right. So what we're going to do today is we're going to actually look at a couple examples of how to graph. So if you don't have a calculator, get you a calculator for me, please. I think y'all have more room now than y'all did before, don't you?
Yeah.
That's super old. Kaylee, do you have the Unit 6 papers, or have you been out from all of it?
I was out Thursday and Friday.
It's the same ones from before. The one that starts like this.
Uh-huh.
And then do you have...
Where's this thing? Is that in here?
It's in here.
Okay.
It's all the way over at 6.4, I think. 6.4? Yeah, we're at 6.4, and then it's the... Gotcha. And then you have the homework sheet too?
Yes.
Okay. You feeling better?
I am.
We were very worried. We were very worried.
We're not.
Is she sick?
I mean, she was when they were both.
Goodness gracious. All right, so what we're going to do is we are going to plug in values from -2 to 2. So we're going to plug into this table, and we're going to plug in x is -2, -1, 0, 1, 2. So when I say to plug that in, we are literally just going to plug that in for our x. So what is 2 to the -2 power? Use your calculator and tell me. 2 to the -2 power. 0.25. Okay, you could have also written that as 1/4. Either way works. What is 2 to the -1 power? 0.5. Or we could have written that as 1/2. 2 to the 0 power?
0. 1.
1. Okay, anything to the 0 power is 1. Okay, it can't be 0. 2 to the first power? 2 to the second power?
4.
Perfect. So now we're going to take those points and we are going to plot them on our graph. So we're going to go to x is -2, and then we're going to go up to 0.25, right in there somewhere. Then we're going to go to -1 and go up to about 0.5. Can you get that exactly on there?
Yeah.
No, you can't. Just get it close, okay? Now, at 0, what do I need to put on the graph? What is the y value when x is 0? 1. Okay. What about when x is 1? Y is? Okay. When x is 2, y is 4. So we are going to sketch on here our graph. Now, as I'm drawing this, should I draw my line to touch the x-axis? Yes or no?
No.
No. Okay, so whenever you're drawing it, be super careful. Try not to touch. You can get it close, but don't touch it. And that is what our graph should look like. Now, what is the domain of that? Does it ever stop going left? No? Does it ever stop going right? Also no. So what would my domain be? -infinity to positive infinity. Now for range, what's the value that it can get close to but not touch?
0.
So we can go from 0, and it can it go, does it ever stop going up?
No.
So it's going to go,
0 infinity.
Now it cannot equal 0. So do I use a parentheses or a bracket?
Bracket.
It cannot equal.
Parentheses.
Parentheses. Parentheses is not equal, okay? Now, what is my y-intercept? What's the point of my y-intercept? How would I write it as a point, though? 0, 1. And then for our asymptote, we're still going to write y equals. So it'll be y equals what? 0. And is that growth or decay?
Growth.
Growth. Yes, Adana? So, do y'all remember when we did graphing of absolute value functions, like graphing like the V shape, and how we moved it around just by either adding or subtracting in certain spots? We're going to do that same thing tomorrow with these, but whenever it is just written like this, and it just has a singular power of x in the exponent, it's going to be 0. The only time it would get changed is if you have something being added or subtracted out here. That's the only time something would change. Yes? And then it'll just change to whatever that number is. But we'll talk about that more tomorrow. All right, for number 15, we're going to do the same thing. We're going to go look at a table for x and y, and we're going to go from -2 to 2. For what we're doing now, we're pretty much going to stick around there. All right. Just by looking at this equation, before we graph it, is that a growth or decay function?
Okay.
Decay. Why is it a decay function?
Dividing.
Well, not even that it's dividing. It's because that b is what? Less than 1. All right. So, and I noticed there was a typo on this paper. So up here at the top, okay, change this to greater than 1 and change that to less than 1. Just change those zeros into ones. I noticed that was a typo earlier today. All right. So now we're going to plug these into our equation, okay? Because we know this is going to be decay because b is less than 1. So if I plug this in, we can type this into the calculator just like it appears. 5 parentheses 1/2, close your parentheses, raised to the exponent. So what happens when we raise our exponent to -2? Use your calculator and find out for me. It is what? 20. What happens when your exponent's -1? Yes?
Can I use a bathroom?
When Casey gets back. What was the answer to that? Okay, what about when 0? 1?
2.5. 1.25.
And what was the next one?
1.25.
1.25. Miranda, Lola, stop talking for me, okay? All right. Now let's graph this. So at -2, 1. Or at -2, where does my point need to go? 20. Can I put that on this graph? No, so I don't need to worry about it. But -1, 10. Can I put that on here? So let's put that point there. All right. Then we have 0, 5. 1, 2.5. 2, 1.25. Then we are good to sketch on here our graph. So again, where can I get really, really close to but not touch? The x-axis. So that is what your graph should look like. And again, you should not touch this line because that is your asymptote. That's okay. I just need to see that it's getting close because I know we are not going to do these down to the point 0,001, right? We are going to do them very show the direction it's going, show what line it's going to. We're not going to be worrying about making sure it's absolutely perfect in the location because there's no way for us to really be perfect whenever we're dealing with such tiny little numbers. All right, now what's my domain? Negative infinity to positive infinity. What is my range going to be? 0 to infinity. Where is the y-intercept this time? Is the point 0, 5. The asymptote is y equals 0. There we go. All right, so that is all of the new information we are talking about today. So what I want y'all to do is I want y'all to get your yellow, that was bad. That was my southern accent really coming out. Your yellow packet out. That's one word I have to fight to say correctly is yellow. It is my favorite color. But the southern accent in me really wants to say yellow sometimes. It's a problem. It is not yellow. It is yellow. All right. So we are going to look first at homework 6.3 in our yellow packet. Okay. That is the one that looks like this. Okay. So what I'm going to do is I'm going to go over half of these questions and I'm going to leave half of them for you to do. So all in all, you are going to be responsible for completing 6 questions. That's it. Okay. So For 6.3, the questions that you need to do on your own are 2, 4, and 8. And we're going to go over the rest of those together. So let's go ahead and look at number 1. Okay, number 1 is just like the question we just did. Okay, we're going to set it up with X and Y in a table. And we're going to plug in -2 to 2. So use your calculators. What is 3 to the -2 power? 0.1 repeating. I would also accept 1/9 as the answer for that. Okay, what about -1 or 3 to the -1 power? 0.3 repeating. I would accept 1/3 for that. What about 3 to the 0 power? 3 to the first power? 3 to the second power. Perfect. Now let's put these on here. So we're going to do -2 to the 0.01, so that's almost touching our line. -1 to the 0.03, that's almost at a half. 0, 1, 1, 3, 2, 9. That's our graph. Then we sketch this. And we get that as our shape. Is that a growth or decay function? And we know that it is growth because our b up here is greater than 1. Because does this one have an a in it? Is there anything being multiplied in the very, very front? Mm-mm.
Why you got a point all the way down there?
Where?
All the way down there at the end of the line.
That is not a point. It's an arrow showing that it keeps going. Yeah. It's just an arrow saying it's going to keep going. Is that better?
Yeah.
All right. Now, you're going to have to do 2. We're going to go through all of the ones that I'm going to go over first, and then I'm going to let y'all work on the rest of them so I can help whenever we need help. For number 3. So we have a table, and we're going to have to write the equation from it. So initial value, that is our y-intercept. What is the y-intercept of that table? It's the point 0, comma, what? 4. So our a value is just 4.
How you get that?
Because that is our y-intercept. So that is where we get that from. Initial is just talking about our y-intercept.
Okay.
All right, now, to go from 4 to 2, what number would I need to multiply by? Divide by 2, which is the same as saying what? Multiplying by 1/2. To go from 2 to 1, I would also be multiplying by 1/2. Go from 1 to 1/2, same thing, 1/2 to 1/4. And so what does that make our constant ratio? 1/2. And so now we are good to write our equation. Okay, we do f of x is equal to a times b. So what is a? And then times b, what's b? To the what power? X. And that is our answer. Yes. Yes, ma'am. All right, now we have a graph. Same thing, okay? What we're going to do, though, is we're going to find points on there just so we have points to go off of. So when x is 0, what's our y value? 0.5. When x is 1, what's our y value?
1.
When x is 2, what's our y value? When x is 3, what's our y value?
4.
When x is 4, what's our y value?
8.
Okay, so we have plenty of information there. Using that, we have to first find our initial value. What is our A from this graph? 0.5. So you could say 0.5 or you could say 1/2. Either way works. Now we have to find our constant ratio. So that is our B. So if I was going to need to multiply 0.5 to get 1, 1 to get 2, 2 to get 4, and 4 to get 8, what number would I need to multiply by?
2.
Times 2 each time. So what does that make my constant ratio? 2. And now we are good to write our function. So f of x is equal to, what's our A? 1/2 times our B is what? 2 to the power of what? Perfect. And that is how we'll do that. So let's go ahead and flip to the back of that. So you are going to be responsible for working 2 and 4. And on the back, you will also be responsible for working 8. Okay, this is the same thing. Okay, it's just giving you words with a table. We are not going to do 6 and 7. So you don't have to worry about those. So once you get that part marked, we can go ahead and look at 6.4, which is actually our growth and exponential function part. So for 6.4, on your own, you are going to do questions 1, 5, and 6. There is one thing I want to point out about question 1. Question 1 gives you your equation. So would you have to find the equation for question 1? No, it gives it to you, okay? So if you evaluate anything with any other equation than that one, you'll get it wrong. But other than that, let's go ahead and look at number 2. So in this one, it says, in 2006, there were approximately 233 million cell phone subscribers in the U.S. During the next 4 years, the number of cell phone subscribers increased by 6% each year. Okay. So what is our A in this one? What's our initial value? Set up, Aiden. 233 million. Okay, that is our A. Now, when I plug that in, do I have to rewrite that as saying 233 million and 0? Like, do I have to rewrite it as the big fuel number? No, I can leave it as 233, okay? But what am I going to have to make sure I do at the end? Put that million back into it, right? We have to make sure we have our answer written in millions. Now, does this question give us our B value, which does mean, does this give us something that we're multiplying everything by, or does it give us a rate? And by rate, I mean some percent. It gives us a rate, right? It gives us a percent. So it gives us a percent. What percent does it give us? 6%, okay? So because it gives us that as a percent, okay, that right there is our R. And we do get it as 0.06. Okay, so since I have an R, since I have a rate, am I going to plug it into the formula with the B, or am I going to plug it into the formula with the R? With the R. Now, in this particular question, it's telling us that the number of phone numbers is increasing or decreasing? Increasing. So since it's increasing, is that going to be decay or growth? Growth. So do I need to say 1 plus R or 1 minus R?
1 plus R.
Perfect. So let's write this equation. We're going to do f of x is equal to 233 times 1 plus 0.06. And what power do I need to raise that to? Do I need to raise it to the fourth? This is just want us to write an equation. Yep. So I wrote this in terms of X, which is fine. If I would have read the question better, it would have said T years, and that's my bad. I'm not going to count off if you do the same thing I just did. But I need you to, like, that was just my bad, okay? So we could have wrote that with T instead of X. Now, the next one, it says estimate the number of subscribers in 2018. How big of a gap is it from 2016 to 2006 to 2008?
2 years.
2 years. So what do I need to plug into that function?
2.
2. So we're going to find f of 2. So we're going to do 233 times 1.06 to what power? To the second power. And when we do that, what do we get?
61.79.
Okay, so we could do 261. Let's just do 1 decimal place. So point.
0.8.
Now, should I leave my answer written like that, or what word do I need to attach to the end of that? Million, okay? We have to make sure we keep any units that are in there, including money units, included. Now, I could have done it like that, or I can write my answer as like a number. So how would I write that out as the full number? I could have also wrote it as that. All right, now we're going to go ahead and look at number 3, okay? So I want you to read number 3 for me real quick. Read it quietly, okay? And I want you to look at it and think about what it gives you. So what is our initial value in 3? 50. Okay, that is our A. Now, does this give us a percent or like that we can see as a rate? Does it give us a rate that we can see as a percent? Does it give us a percent? No. What does it tell us is happening to our number? It quadruples each day. What does it mean to quadruple? Does it go up by 4 or go up times 4? Times 4. Okay, so this problem, did it give us a rate? Did it give us a percent? No. If it doesn't give us a percent, will I use the B or will I use the R? The B. If it does not give it to us as a percent, we have to use the B formula, okay? So, that right there tells me that my B is, what do I have to multiply by to get the next number? What's happening to it? It's quadrupling, so that's 4. So first, let's write our equation. So we get P of T, because it tells us on this one, is equal to what? How would I write my equation? What's my A? 50. Then we're going to multiply that by, what's my B? And then if it's just the normal equation, what power does it need to be raised to? The what? The T, or the T power. The power of T? The power of T, I feel like is the way to say that. Now, okay, so it said write the exponential function. So we did that part. We did the write the exponential function part. Then it says, what will the size of the colony be after 5 days? What do I need to do to find that? Plug in 5. So I want you to take and plug 5 in to that so we can get our answer. What was that? 51,200. That is a lot of bacteria. And yes, most bacteria does multiply at an exponential rate, which is mildly terrifying when you think about the amount of bacteria on everything, but like it's fine. All right, now we're going to look at number 4. Okay, so is number 4 one of the normal growth or decay functions? What kind of one is that? It's a compound interest formula, isn't it? So I have to find P, which is my what? Principal. My R, which is my rate. N, which is the number of times it's being compounded. And T, which is the time in years. Okay, so let's look at this one right here. What is my principal from number 4? What's the principal amount? Perfect. Then for rate, it gives us rate as a percent. Is that what I need to plug into my equation? How do I need it to plug in my equation?
0.035.
0.35. Then we have our time in years. How many years is it? 20. And then how many times is it getting compounded?
Monthly.
So if it is getting compounded monthly, what is N going to equal? 12. And that is what we plug into our equation. So we will get an amount is equal to our principal times 1 plus our rate divided by the number of times we compound raised to the power of number we compound times what? The number of years. So if you take and use all that information and plug that into your calculator, it will tell you how much money is going to be in the account after 20 years. And how many decimal places do we round money to? 2. So go ahead and plug that in and tell me how much money we get.
7,543.
Perfect. And that is our answer. Okay, so you are responsible for questions 1, 5, and 6. Okay. So I want you to work on those 6 questions. And if you need help, raise your hand and I will be there. Yes, ma'am.